Hi folks, hi everybody. I'm Phil from Datavail. First of all, thank you to the Data Summit for having me. It's a terrific experience here, and thanks for Pete for giving that great talk before here. I know we're right before lunch, so people are in that kind of antsy mode, thinking about what we're going to talk about and whether it's really relevant to sandwiches. It's probably not, but I hope I can keep you guys entertained for a few minutes while we talk about how you can build better culture, empower developers by focusing on some of these keywords that are important to folks, DevOps, and most specifically, as is important to me and to I'm sure a lot of the folks here, DevOps, particularly as it relates to the database. And here we go. Certainly what we're going to talk about, I like to make sure that everybody has an understanding of the terms we're going to use. It might be a little bit of a review for some folks, but for some people, there might be some of these things that they've heard the term culturally, but they don't really specifically have a hands-on idea of those things. We'll talk about some of the challenges that come with platform engineering, particularly as a practice that has sort of grown in recent years. And towards the end here, we'll get to some things that might be real tactical and real helpful to folks in terms of how do you build a strategy that works, and maybe just as importantly, what are some things that people have done in practice that don't work so well and lead you down the wrong path. As I said before, my name is Phil. I am the practice leader for Datavail's global Postgres practice. I bring engineering experience both on platform teams as well as leading development teams, database-focused teams, operational DBA work. I've certainly worked in a lot of different areas in that way. And certainly one of those people who gets called late at night when a database stops working or an integration system isn't there. So happy to talk about those kinds of things, tell war stories, any of that. Track me down. We can certainly have a conversation. Who are we? We're Datavail, and we put this slide together. If you're looking for us out in the vendor booth, we're the ones who have the Legos. So make sure you fill out an evaluation, and make sure you stop by our booth if you want to get if we can scan your badge, you'll get entered to win a Lego set at the end, and we'll talk to you a little bit about who we are and what we do. I'll tell you very briefly what Datavail does. We're a data strategy company. We focus on helping customers expand both self-hosted as well as helping them with database as a service or DBA as a service. We do data strategy, we do SRE, we do pretty much any kind of talk that revolves around data. We've been in business for more than 18 years, and we have a global team with more than 1,300 employees. So if you have questions about data, whether that's open source sort of technologies, I'm focused on Postgres. That's what I do all the time, but our practice is split into a number of different areas. So whether it's Microsoft, Oracle, Snowflake, any of those things, we've got people who we can talk to you about or who can talk with you. So what is this term? DevOps isn't a new term. It's been in the culture now for a couple of years. I'm sure plenty of people have ideas about what it is. And it comes from the convergence of the developer culture that really grew and operational need. So some examples of what represents these things in DevOps are the infrastructure as a code. We see real growth where once upon a time infrastructure existed as this thing that somebody went out and configured a system, logged into the system, took care of things, and if they needed to make a change, they SSH'd over to that machine and they logged in and they made a change and they took care of it. Infrastructure as a code says, hey, we should treat operational systems the same way we treat source code. We wouldn't go make, some people might, but we wouldn't go make front-end systems where if we need to make a change, somebody logs into the system and edits the code on the fly, and that's not how we build products, not how we ship features. We take those same mentalities of building product and shipping feature and apply it to operational systems, whether that's in containers or whether that's in virtual machines or whether that's in whatever the next big thing might be. We focus on CI/CD, we focus on metrics, monitoring, and observability. Those are all great terms, and any one of those things could be a deep dive on a talk. We've only got a few minutes here to talk about stuff. So one of the things that's really important about DevOps is that it's focused on shipping product. I hope most people who have some sort of product or work in a product-focused organization, the answer isn't about using cool toys or doing cool things. It's about getting product in front of the customers and shipping the next feature that's important to them. That's really the DevOps mentality. And most importantly, it's about reducing friction to make sure those features can be deployed. So one exercise you might hear people talk about is value stream mapping. It's something that gets talked about a little bit in the literature. Value stream mapping is very simple. It's making a diagram, and it's looking at that diagram about how many steps does it take from when a product manager comes in and says, here's what we need to do next for our product. How long does it take it to, how many people does it have to go through, how many teams does it have to get siphoned through before that feature is actually deployed in production to a user and that user can use it. You're certainly hear that DevOps is about eliminating silos. That's very much what it is. Not saying that you don't ever need database-specific people or operational-specific people, but saying that those people work in a more integrated fashion in the enterprise. And DevOps is developers being operational people. So people on the developer side owning both their systems and their code. And lastly, you've probably heard this old chestnut. If you haven't, it's worth noting. DevOps is a philosophy, it's not a job description. So DevOps is something that kind of comes into the organization as a whole. That's not to say, and we all know perfectly well, if you go look at the job listings, there are certainly jobs called DevOps engineer. What is that person? I mean, they're probably a sysadmin of some variety or a cloud engineer or something like that. But conceptually, you can always fight that fight and say DevOps isn't a job title. It's what we all do. It's what all the engineers and the product people and everybody do together. So from there, where do we go next? The newer, hotter buzzword term is platform engineering. Is platform engineering DevOps? Well, yes, you can embrace a DevOps philosophy to supporting the platform. So what is the platform engineering about? It's a real tactical way to answer that question. How do we remove that friction for developers? It focuses on internally for an organization, what is that methodology that the development teams specifically go through in order not just to ship product, but particularly to provision, to instance, to get access to the resources on the cloud in a simplified way, in a way that reduces that experience for them where they have to jump through a lot of hoops. This is very applicable in very large organizations. It's just as applicable in startups. It's about focusing on building the tools for those developers that reduce their friction to saying, from going, hey, I need a database in this region. Once upon a time, very similar to how sysadmins would SSH to the machine and provision that machine. Nowadays they go to the AWS console and they find the region and they click on it and they say, provision that for me. And yeah, that works when you're an organization of 1 or 2 people. It does not work so well when you're a very large organization. You lead to feature sprawl and system sprawl and spending sprawl, most importantly. So, one of the things that platform engineering focuses on is building developer success metrics. In order for your developers to feel empowered, you need to understand what it takes. Again, like I say, it's part of that value stream map. Whether you draw a pretty picture or not, what you're trying to figure out is what does it take for your developers to get the job done, and how long does it take them? So you need to start building metrics before you start talking about how you're going to change the culture or what you're going to do in that culture. You need to be writing down how long does it take. You need to measure these things the same way you would measure operational success for any kind of system. Have metrics and record those metrics. Time to release a feature, time to get a fix into production, time to deliver new infrastructure is also one. So previously speaking, how long would it take if somebody had a request and said, we need a database that goes to production and we need it in all of our lower environments? How long did that take before? And is your platform team building success by reducing that time to deliver? The real goal is developer self-service. That is to say, the developers really want to get to a point where they can say, I want a database and I don't want to make a lot of decisions about it. I just want it to be there. A lot of people think, and we'll talk a little bit more later in the talk about one term you might hear in relation to platform engineering is the internal developer portal, the IDP. The IDP is another famous 3-letter acronym, TLA, that you'll see thrown around a lot. People think that the portal is the solution. They think the portal is the platform engineer. Portal's kind of the last step. IDP is one possible way to provide value to your developers, to your engineers, to your engineering culture, but it's usually an iteration. We're going to rock through these next couple of slides because, again, so much to talk about. But the most important thing to remember is that the point of platform engineering is that developers are going to make decisions, and those decisions need to have guardrails. You don't want to stop your developers from building things. You don't want to slow them down. What you want is to put them in a position where they make successful choices. So what is it about stateful data that makes that harder to do than just provisioning containers and things like that? It seems like it's pretty easy. I can go to the console, I can click build me a database, and it does. The problem is that sizing and tuning production systems is really tough, and people know that instinctively. Relational databases scale up easily, they don't scale down very easily. People who talk about, well, I just use AWS serverless. Well, serverless is very much a misnomer. It still runs on hosts. It still has hardware. It might separate the concern of compute from the concern of storage, but ultimately you're still running systems. And also, serverless scaling can be very expensive. The pricing model of it doesn't necessarily line up with what people need, especially if they need 24/7 availability. So, and equally well, the challenges of the database can be very significant. Schema changes block, settings changes require restarts. These are things we know about database systems. Those sorts of problems can't run at the same time as deploy all the time, move fast and break things, these kind of cultural things that get really embraced by the developers. I was going to tell you a little bit more about Postgres specifically because it's so dear to my heart, but I will just say in general, understanding Postgres is a difficult thing, and telling the developers that they should just figure out how to scale Postgres, they usually run into one of a number of different problems. So let's get to the two most critical slides I have are these two. What works and what are the pitfalls? What works is having organizational buy-in that starts at the top. That means finding executive champions who believe that empowering developers is important. It doesn't come from having developers who go forward and say, guys, did you know that we're not really empowered here, we don't know how to make changes. You have to have a champion, and I think it's important to find executives who really support the engineering team. You need to have success metrics, and you need to look at them. You need to look at small wins and iterate on them. You should focus on automating the smallest thing that will make a meaningful improvement to a developer's life. That might be creating clear, automating tickets, automating pull requests, things like that happen so that the developer doesn't have to be going through all the boilerplate action that they might do otherwise. And most importantly, you have to have a feedback loop. So as you make changes, you need to be talking to your developers and say, did I make a change that made your life better? Or did I put something in place that you're not going to use or that actually put more obstacles in your path? So get feedback from your developers regularly, especially if you're trying to build platform engineering. What are the common pitfalls? Focusing on the tooling over the metric. So you'll often hear people say, and in fact, I've talked to many people who work in other organizations where they say from the top down, somebody said, we're going to put in an IDP, a development platform. So we signed a contract with Backstage, or we looked at some other tool, and that's what we're doing, and it's going to power, and that's going to solve the problem. That is not the answer to the problem. Okay, the answer to the problem is knowing what is your developer obstacle. Secondly, they might say that the platform engineering team now has to solve all the problems. They have to start at the beginning. They have to make it so that by next year, a developer just pushes a button and they get a database that provisions. Well, that small part of it, maybe you can fix one of it, but you can't have the tickets and the pull requests and the deployment all just be there. You can't solve all the problems in one chunk. One of the major pitfalls that you'll see is people trying to invent a new communication platform internally. This kind of dovetails with Conway's Law, which is to say that organizational systems resemble the communication culture within that organization. If you're trying to empower your developers, don't make them have a whole new thing to go through. If you have a ticketing system that already works, use that ticketing system. If most of the communication happens in Slack in your company, then your platform engineering team should be focused on Slack channels, Slack bots, those kind of things. If you're a culture that still uses email heavily, then email approvals are where you should be. Don't try and create a new thing and say, even though my culture uses Slack extensively or uses Microsoft Teams extensively, we're going to build our own little app, and it's going to have its own communications channel, because nobody's going to use it. You can tell them to use it, and even with champions on a high, there's still going to be a lot of resistance and friction to using it. Excuse me, I'm getting a little fluttery talking. It's the speed here. Last two common pitfalls, really the most important of all. One of them is trying to overload the team. That goes along with trying to solve all the problems all the time. You have to have a mission. If your organization wants to build a platform team, give that team a mission. Make sure that mission is very clear to them and that they themselves understand what they are trying to solve. Are they there to be just the replacement for your operational engineers? Are they intended to be supportive of all of the infrastructure and all of the delivery? Or do they know specifically what problems they're trying to solve? And lastly, and this is a real tactical one, going in and providing a template. When you're trying to template for your developers to give them something so they can push a button and deploy systems, you, the platform engineer, need to know what the options are for those things. That means you have to have read the docs before it gets to them. So don't give them an all things to all people kind of template. Don't go out there and say, which is very commonly done, people providing a system where they expect the developers to know what all the choices are for that cloud platform. They don't know what it is, you're supposed to know that. Limit their choices, allow them to have guardrails, and make good choices. So with that said, I really thank you all for the time you spent with me. I hope we can talk a little bit in more detail about platform or about data or databases or Postgres. Find us over by the Lego set, and thanks a lot for your time.
All right, thank you.